Mr. Klein here for Klein Maths. So today we're doing the Higher Maths 2025 last minute non-calculator paper courtesy of Chris Smith. If you want to know more about Chris Smith, he does lots of stuff for students in Scotland. Links in the description to get access to his weekly newsletter. Just a reminder that if you're doing Higher Maths this year, 2025, we've got a last minute exams prep video. Well, it's actually a live stream on Sunday the 11th of May at 6 p.m. YouTube members only, but it's only £4.99 to join. So get on that if you want a last minute help the night before the exam. Clever Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code CleverMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include national free 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code CleverMaths to get 30% off that. Link down below. SQA Higher Maths 2025 last minute, paper 1. Question 1. Find the value of p such that this has x plus 2 as a factor. So that's a polynomial. And if it's got x plus 2 as a factor, it means I can sub in minus 2 and the remainder should be 0. There's two ways to sub in. You can sub in directly, or what I think most people do is use synthetic division. So I'll do it that way for you. So synthetic division means you set up a little table. We've got 1x4, 1x cubed, px squared, 5x, and minus 10. And we're subbing in x plus 2, so we're subbing in minus 2. So how does this work? We drop the 1 down. 1 times minus 2 is minus 2. Minus 2 plus 1 is minus 1. Minus 2 times minus 1 is 2. Then we've got 2 plus p. Then we need to times by minus 2, so watch out here. Minus 4 minus 2p. Then I need to add the 5, so that's 1 minus 2p. And then I need to times by minus 2 again, so they get minus 2. Then it's plus, minus times minus a plus 4p. And finally, minus 2 minus 10 is minus 12 plus 4p. And we just got a little statement. Since x plus 2 is a factor, then f of minus 2 should equal 0. Or the remainder equals 0 if you prefer that statement. Remainder equals 0. So that means we can just say that minus 12 plus 4p equals 0. So taking the 12 over and then dividing by 4. 4 threes is 12. P is 3, and we're done there. Let's do a Higher Maths 2025 last minute paper 1 question 2. Given f of x is 8x squared minus 5 and g of x is 4 plus x, find g of f of x and f of g of 3. Okay, I'll do the first bit first. So let's call that A and call that B. So part A, I want g of f of x. That means that every time in g I see an x, I write f of x. So let's start with that then. I've got 4 plus x, 4 plus f of x. And f of x is 8x squared minus 5. So that's 4 plus 8x squared minus 5. 4 minus 5 is minus 1, so it's 8x squared minus 1. Part B, find f of g of 3. F of g of 3, there's two ways to do it. You can find f of g of x first, and then sub in 3, or you can just do it directly. Let's do it directly. F of g of 3. So let's work out g of 3 first. That's 4 plus 3, which is 7. So to work out f of g of 3, that means that in f of x, I've got 8x squared minus 5. I want to sub in 8 g of 3 squared minus 5, because g of 3 is turning into Lx. So that equals 8. G of 3 is just 7, so times 7 squared minus 5. 7 sevens is 49, so that's 8 times 49 minus 5. A little bit of work on the side if I have to. 49 times 8. 8 nines is 72. 8 fours is 32. 32 plus 7 is 39. So I've got 392. Take away 5, which is 390, 389, 87, 87, 387. So I've got 387 and we're done there. Now, if you don't like this method, of course, just remember that you can just work out f of g of x first, and then sub in 3, and that would give you the same answer. SQA Higher Maths 2025 last minute paper 1 question 3. We've got a triangle ABC. Find the coordinates of the point of intersection of the median and the altitude. The median B to P, so we're saying that if I call that point P, because there's not a P on it, it's the line that cuts that in half. I've deliberately not made it right angled because it's not necessarily. And then the altitude C to T, so starting at C, going over to here. I'll try and draw it at right angles, but I'm just going to show a right angle in any case. We're saying that that's a right angle and that's T. So let's work on the median first and then the altitude. We're going to need the equation of both. So looking at our median, for medians, you need the midpoint. So to get P, I just add up -7 and 1 and divide by 2, and add up -2 and 12 and divide by 2. So -7 and 1 is -6, over 2 is -3, -2 and 12 is 10, over 2 is 5. So we'll get -3, 5 for our midpoint. And then, since we've got our midpoint, we don't know the gradient, but we've got B to P, so we can work out the gradient. So B is 2 minus 5. So we've got B is 2 minus 5, and P is -3, 5. So our gradient of B to P is 5 minus -5, y2 minus y1 over x2 minus x1 minus 3 minus 2. 5 minus -5 is 10 over -5, which is -2. And then we need to work out the equation using y minus b is mx minus a. So I'm just going to pick P to be A and B, or you might pick B. I'll pick P though, it doesn't matter what you pick. Y minus B equals M, X minus A, which is -3. Y minus 5 minus 2x add 3. So y minus 5 minus 2x minus 6 minus 2x. Add 5 from -6 is -1. So there's our equation of our median. We need to do the same thing for our altitude now. So our altitude C to T, we can't work out point T at all because it's not in the middle or anything, but we can work out the gradient of A to B, and then M1 times M2 equals -1 because they're perpendicular. So that's my approach. So let's look at our altitude. So we've got our points A, which is -7, -2, and B, which is 2, -5. So our gradient of A to B, y2 minus y1, -5 minus -2, over x2, which is 2, over -7. So that's -5 add 2, which is -3, over 2 minus -7, which is 9, minus a third. And then we can straight away say the gradient of the perpendicular, in other words, TC, equals 3, since M1 times M2 equals -1. So we just flip it upside down and change the sign. Minus a third becomes -3, which becomes 3. And then we need a point. So our point on the line is C, which is 112. So y minus b equals m, x minus a. Y minus 12 equals 3x minus 3. So y finally is 3x minus 3 add 12 is 9. So we've now got two equations. There's our altitude and there's our median. Let's write both of them together. We've got y equals 3x plus 9, and we've also got y equals 2 minus 2x minus 1, and we need to solve them simultaneously. Now you could move all the x's and y's to the same side of the numbers and do it like National 5, but a nicer way, neater way, is if they both equal y, then that side equals that side. So that's what I'm going to do. So I've got 3x plus 9 is minus 2x minus 1. Moving the x's to the same side gives me 5x. Moving the 9 over gives me minus 10. So x is minus 2. And then to get our y, we need to sub in. So y equals 3x, 3 times minus 2 plus 9. That's minus 6 add 9, which is 3. So our point of intersection is equal to our x and our y, and we're done there. SQA Higher Maths 2025 Last Minute Paper 1, Question 4. Work out the coordinates of P, which divides the line AB in the ratio 3 to 1. Now, you could use a section formula for this or otherwise, but I'm going to show you a nice, neat method. So we're in the ratio 3 to 1. So that means that A to P equals 3 lots of P to B, because it's 3 times bigger. Well, what is A to P? A to P is P minus A equals 3. P to B is B minus P. And we have to work out the coordinates of P, so we'll just rearrange for P. So P minus A equals 3B minus 3P. Taking the P's to the same side, you get 4P on this side, and that equals 3B plus A. 4P is 3B plus A, so P is 3B plus A all over 4. Now, you would get there if you use a section formula, but I don't think a section formula makes much sense, but I'll show you anyway. If you write it like this, let's look at our equation, 3B plus A over 4. If I put the 3 and the 1 on the top and bottom, you'll be able to see it better, because you may know this from school. If I put 3 here and 1 here, then you just can think of a little cross here, 3 times B plus 1 times A, 3 times B plus 1 times A, over the total, which is 3 plus 1, which is 4. So you can get there if you want like that, but I prefer to just do it every time instead of memorising a formula. So what is my B? 3, 6 minus 12. So I've got 3 lots of 3, 6 minus 12, plus A, which is 7 minus 2, 0. And then we need to divide the whole thing by 4. I'll just write over 4. Not a very nice way to write it, but you get the idea. So 3 3s is 9, 3 6s is 18, 3 12s is 36, plus 7 minus 2, 0, all still to be divided by 4. 9 plus 7 is 16. 18 minus 2 is 16, and minus 36 plus 0 is minus 36. So you get that divided by 4, or a quarter of that. And then that gives me, finally, 4, 4, and minus 9. And therefore, P, as a coordinate, is 4, 4, minus 9. And we're done there. SQA Higher Maths 2025 Last Minute Paper 1, Question 5. Solve for x, a log equation. So if you've got a log equation, you want to combine all your logs into one log if you can, and get a log on each side, or just at least a log on one side. So rules of logs, the first log, I've got a base x. The 2 can come up to make 6 squared. I'll keep the minus in there now and combine that in a minute. X, 8, and the 2/3 can come up to give a 2/3 in the power position. And that's all equals 2. Taking away logs means divide if the base is the same. So log x, 6 squared, all over 8 to the power of 2/3 equals 2. Let's simplify some of that before we go any further. So that's log x, 36, over 8 to the power of 2/3. Well, 3 in the bottom position, so that's the cube root of 8 squared. So we can work out the cube root of 8 squared, surely. That's 36. The cube root of 8 is 2. 2 2s is 4. So that gives us 4. Well, that's handy because 4 9s is 36. I've got 9 there, that's 2. 4 9s is 36. So then that means that I can say that x to the power of 2 equals 9. So x is the square root of 9. So x equals 3, or x equals minus 3. But x is greater than 0, which it has to be. So x equals 3 is our one-way answer, and we're done there. SQA Higher Maths 2025 Last Minute Paper 1, Question 6. Show algebraically that this function is never decreasing. So it's a cubic, and it's never decreasing, which means that I have to show that the gradient of the tangent is never less than 0. In other words, I need to differentiate it. F dash x, 3 comes down to the front, x, take away 1 to the power. 2 comes down to the front, so that's 2 3s is 6, x, and we'll take 1 away from the power, and then 3x becomes 3. So we've got that, and we need to show that that never decreases. So let's see if we can do anything with it. Can we factorise it? Can we complete the square? What can we do? Take 3 out as a common factor. X squared minus 2x plus 1. Can I factorise that? Well, let's hope so. Yes, you can. Minus 1 is minus 2. Well, that's 3x minus 1, all squared. Now, if you couldn't factorise it, what you could have done at this stage is completed the square and then showed that as long as you've got a positive number on the end, you would end up with it always increasing as well, or at least greater than or equal to 0. Because imagine you had 3x plus 2 squared plus 1. Then what you would have here is that's always positive, plus a positive number is always positive. So as long as you're not taking away anything. So we've got anyway 3x minus 1 all squared. Well, that is always positive. So we can then say that then that is always greater than or equal to 0. So in other words, 3x minus 1 squared is greater than or equal to 0. And therefore the function is never decreasing. So since f dash x is always greater than or equal to 0, function is never decreasing. And we're done there. SQA Higher Maths 2025, last minute paper 1, question 7. The vector a half I plus tj minus a half k is a unit vector. Find the values of t. Basically the question actually, do you know what a unit vector is? Maybe you don't, but I'll tell you. A unit vector is a vector of size 1. So in other words, the modulus of that vector is 1. So modulus of u equals 1. How do we find the modulus of a vector? You square each of the coefficients, add them up and square root it, like Pythagoras. So I've got the square root of a half squared plus t squared plus minus a half squared equals 1. It should be obvious that a half squared plus a half squared. So we've got a half squared is a quarter plus t squared plus another quarter equals 1. So in other words, we've got the square root of t squared plus a quarter is a half equals 1. And we just square both sides to get rid of that square root sign. So that gives me t squared plus a half equals, well, just 1 still, because 1 squared is 1. Taking away a half from both sides, we get t squared equals 1 half. And therefore t is the square root of a half. So in other words, t equals, I'll write it as 1 over root 2. And t equals, well, you get a minus answer when you square root, so minus 1 over root 2. And we're done there. SQA Higher Maths 2025 last minute non-calculator paper, question 8. Solve for x between 0 and 2 pi, which are radians. 2 sine squared x plus 4 equals 5. So it's just a trig equation, nothing's fancy. I take the 4 over to get 1, divide by 2 to get a half, and therefore square root on both sides, sine x equals 1 over root 2 plus or minus 1 over root 2, because when you square root a number, you get a negative answer. So we're looking at 1 over root 2, that's an exact value. So your exact value triangles, the way I remember them is I've got 1, 2, 3, and that's my 60-30 triangle. And the other one you've got is 1, 1, 2. 1, 1, root 2, and that's my 45 degree. The only one with root 2 is the 45 degree one, so the sine of 45 is 1 over root 2. Well, what's 45 degrees? 180 divided by 45 is 4. So 45 degrees is pi over 4. So that means that x equals, as a basic thing, the inverse sine of 1 over root 2. I'll not even write x at the moment, I'll just write inverse sine of 1 over root 2, which equals pi over 4. And now we need a cast diagram for all our answers. Well, we've got positive sine, and then it's negative, so we've got them all. So that means that x equals pi over 4. This one's usually 180 minus, but it's going to be pi minus the angle. So I need to do pi minus pi over 4. That's 4 pi minus 1 pi, which is 3 pi over 4. That's pi plus the angle. So pi plus pi over 4. That's 4 pi plus 1 pi is 5 pi over 4. And then 2 pi minus in this bit. 2 pi minus pi over 4. Well, 2 fours is 8. So that's 8 pi over 4 minus pi over 4, which is 7 pi over 4. And just checking our initial conditions between 0 and 2 pi. So we're done there. SQA Higher Maths 2025, paper 1, last minute, question 9. Here's a graph of y equals a log 2 x minus b. What are the values of a and b? I always think of this in terms of graph transformations. But you can also think it in just terms of subbing in numbers. I'll show you both ways. A normal log graph goes like that, roughly. And that's the point 1. It's always 1, 0. This is the same, but it's moved to the right by something and then been stretched. But the moving to the right part is moved to the right so that this is 5 from 1. So that's out to the right by 4. That immediately tells me that b, since it's x minus b, minus means moved to the right, that b is 4. And now to get my a, well, we've got the point 0.86, so that's an x and a y, so I'm going to sub in. So y equals a log base 2 x minus 4 now, and y is 6 and x is 8. 6 equals a log 2 8 minus 4. So 6 equals a log base 2 of 4. Well, what's log base 2 of 4? That's asking me 2 to the power of what is 4? 2 2s is 4. So 6 equals 2a, because log base 2 4 is 2. So that means that a equals 3. And we're done there. There's a couple of ways to think about this question. Initially, you could have just took this equation here and said we've got 5 along, 0 up. So x is 5 and y is 0. Sub it in and then try and get your a that way. And try and get your b that way. Similarly, at this point, when we're doing this equation, if you can't think of this, then what you can do instead is you can take the a up to the power position, 4 to the power a, and say that 2 to the power 6 equals 4 to the power a. And that will get you a equals 3 with some manipulation. But I think this is the quickest way to do this question. Okay, SQA Higher Maths 2025, last minute, paper 1, question 10. Express 5x squared plus 10x plus 2 in the form px plus q squared plus r. So completing the square. So how do you complete the square at Higher Maths? Well, if there's a number in front of x squared, you literally just factorise the first two things, leaving the 2 to the side. So I'm going to say I've got 5, just go x squared plus 2x, and then plus 2 just hanging out. So that's 5, and now I'll complete the square in the x squared plus 2x part. So it's the same as National 5 now. X plus 1, half the term, squared, and I immediately take away 1 squared. 1 squared is 1, so minus 1. That's stuck inside the bracket with a 5. And then plus 2 is hanging on the end. Now get rid of my bracket, a big one anyway, so I've got 5x plus 1 all squared, minus 5 plus 2. So I've got 5x plus 1 all squared, minus 3. And we're done there. SQA Higher Maths 2025, last minute, paper 1, question 11. We've got a triangle with defined sine 2 theta, cos 2 theta, tan 2 theta. Right, so I'm going to find any of that. I might as well just work out all my sizes on my triangle first. So using Pythagoras, 2 2s is 4 and 3 3s is 9. 9 plus 4 is 13. So the hypotenuse is 13. And now before I do any of it, I might as well work out my sine, tan and cos of each of them in case I need them. I'll probably not need the tan one, so let's just do the sine and the cos. So the sine of theta, opposite over hypotenuse, and the cos of theta, adjacent over hypotenuse. And now I'm going to begin. Part A, sine 2 theta, start of the exam paper is 2 sine theta cos theta. So I'm going to sub in 2 times 3 over root 13 times 2 over root 13. So that's on the top, 2 twos is 4 times 3 is 12. And on the bottom, root times 13 times root 13 is just 13. So we're done there. Cos 2 theta this time. So the exam paper for that one gives you a number of formulas, but I'm going to use 2 cos squared theta minus 1. So cos 2 theta, 2 cos squared theta minus 1. It doesn't matter what one you use, you'll get the same answer. Cos squared theta, well, 2 over root 13 is cos theta. So it's 2 over root 13 all squared minus 1. That's 2 times 4 over 13. 2 twos is 4. Root 13 squared is 13. All minus 1. 8 thirteenths minus 1. So to take away 1, that's taking away 13 over 13. So 8 minus 13, which is minus 5. So you get minus 5 over 13. And we're done there. Well, we've not got a trig identity for part C, tan 2 theta, but we do, because tan is sine divided by cos. So tan 2 theta must be sine 2 theta divided by cos 2 theta. So that's all you're doing for part C. Tan 2 theta, sine 2 theta over cos 2 theta. What does that equal? Sine 2 theta is 12 thirteenths. 12 thirteenths over, or divide, I suppose you could think of it as, minus 5 thirteenths. That's 12 thirteenths times 13 over minus 5. So the 13's cancel to leave 12 over minus 5. Don't leave a minus on the bottom like I've done though, put it to the side or on the top, minus 12 over 5, and we're done there. SBA Higher Maths 2025 last minute paper 1 question 12. Which coordinates do the line y equals x plus 1 in the circle share? In other words, what's the point of intersection? So point of intersection means simultaneous equations, and simultaneous equations between a circle and a straight line. The easiest way to do it is sub in the y into here or the x. So I've already got y equals x plus 1. So every time I see a y in the circle, I'll write x plus 1. So I've got x minus 2 all squared plus y, which is x plus 1 minus 4, equals 13. So that's x squared minus 4x plus 4, expanding x minus 2 all squared. And this one is x minus 3 all squared, so that's plus x squared. 3 2s is 6, so minus 6x, and 3 3s is 9, and that equals 13. So that's 2x squared minus 10x. 9 plus 4 is 13, and that equals 13. So move everything to the same side. 2x squared minus 10x equals 0. 2 is a common factor, x squared minus 5 then. 2x is a common factor to get x minus 5. So x equals 0, or, well, x minus 5 is 0, so x is 5. It says which points, in other words, coordinates. So y equals x plus 1. So when x equals 0, y equals 0 plus 1, which is 1. 0, 1 is one of the points of intersection. And when x equals 5, y equals 5 plus 1, which is 6. 5, 6 is the other one. And we're done there. SBA Higher Maths 2025 last minute paper 1 question 13. What value of k does this equation have equal roots? Well, we're talking about equal roots, so we're looking at the discriminant here. So we're looking at b squared minus 4ac equals 0 for equal roots. So b is 20, so 20 squared minus 4 times k, because a is k, and c is 40. So working out 20 squared, that's 400. 4 40s is 160, so minus 160k. Taking the 160k over to the other side. So k is 400 over 160. So I can divide by 10 to get 40 over 16. 4 10s is 40, 4 4s is 16. Oh, there's a bigger number went in, 8 I suppose. But then divide by 2 to get 5 over 2. k is 5 over 2, and we're done there. Basically, Higher Maths 2025, last minute, paper 1, question 14, calculate the shaded area. So if you've got a shaded area at Higher Maths, usually it's integration. So we've got an upper curve and a lower curve, or line. Our upper is the parabola, which is this one, minus our lower, which is that one. And we've already been given where they intersect, minus 3 and 1. So the shaded area is equal to the integral between minus 3 and 1 of f of x minus g of x dx. So what's f of x minus g of x? Well, let's just write it out. F of x is 6 minus x squared minus g of x, which is x plus 3. I'll put that in brackets because it's all of g of x. So what does that give me? That gives me minus 3 and 1. I've got 6 minus 3, which is 3, minus x minus another x is minus 2x, and I've still got minus x squared dx. So I need to integrate all that. So integration, add 1 to the power divided by the new power. Numbers just get an x, so I've got 3x minus 2x squared over 2 minus x cubed over 3, and I have to do that between minus 3 and 1, which means I need to sub them in. I'll simplify it first. 3x minus 2 divided by 2 is just 1, so minus x squared, and then minus x cubed over 3, or minus a third x cubed. Always get a mark for subbing in, so put the actual substitution in, don't do anything yet. So that equals 3 times 1 minus 1 squared minus 1 cubed over 3, that's my first big bracket, minus my second big bracket, 3 minus 3's, minus minus 3 squared minus minus 3 cubed over 3. So I usually get a mark there, and then I only get another mark once I've worked it out. So a lot of people just make a mistake at this point, but as long as you've subbed in, you're only going to lose 1 mark. Let me see if I can work it out exactly. 3 ones is 3, 1 ones is 1, 1 cubed is 1, so that's the first bracket. Simplified, minus 3 times minus 3 is minus 9. Minus 3 squared is 9, but I've got another minus, so minus 9. Minus 3 cubed is minus 27, but I've got another minus, so it's plus 27. But over 3 nines is 27, so plus 9. That gives me 3 minus 1 is 2, 2 minus a third is 1 and 2/3. 9 minus 9 is 0, and then I've got another minus 9. So minus minus 9 plus 9, which is 10 and 2/3 units squared, and we're done there. Obviously, you can leave your answers 32 over 3 if you prefer. SQA Higher Maths 2025 last minute paper 1 question 15. Solve 2x squared plus 3x minus 20 is less than 0. So this is a quadratic inequality, and to solve them you find the roots as if it's equal to 0, but then you draw a little graph to show where it's less than 0. So let's examine the roots first. Roots of 2x squared plus 3x minus 20. So I'll make that equal to 0. Hopefully it factorises 2x and x. So I'm looking for 2 numbers at times to make 20, and I need to get 3 in the middle. So probably 4 and 5. Usually try the numbers closest to each other first, because 9 times out of 10 they work. So 2 5s is 10, and then 3 4s doesn't work. 2 4s is 8, and 5. Yeah, 2 4s is 8, and then 5. There's obviously methods for factorising. If you need help on that, look at the National 5 stuff. But in any case, I'm looking for plus 8 minus 5 is 3. So that means that one of my roots is there, and the other one is here. So x equals 5 over 2, or x equals minus 4. And now draw a graph. Now it was a positive x squared, so it's a parabola going down the way. And I want it between minus 4, let's just shove minus 4 there, 5 over 2, say there. I don't need to know where it turns. Just need a graph. That's y and that's x. And if we look at our original question, what's it less than 0? What is less than 0 below the x-axis? So in between these two numbers is when it's below the x-axis. If it was greater than 0, I would want either side here. So in between minus 4 and 5 over 2. So our answer is minus 4 is less than x is less than 5 over 2. And we're done there. SQA Higher Maths 2025 last minute. Paper 1 question 16. Show that y equals x cubed and y equals x plus 1x squared plus 4 have exactly one point in common. Point of intersection means simultaneous equations. So we're both y equals, so that means that I can just make the right-hand side equal to each other. Now, if we're going to want to solve an equation with a power, I need it equal to 0. So I'm going to expand my brackets. X times x squared is x cubed plus 4x plus x squared in the middle, and then plus 4 in the end. And that means taking everything to the same side, well, the x cubes will just cancel to give x squared plus 4x plus 4 equals 0. If it's got one point in common, it means there can only really be one solution to this. Two ways to show. Do the discriminant. If the discriminant equals 0, then it's two equal roots. Or just solve it. You'll get two answers the same. I'm just going to solve it if it's solvable, factorizable. If not, I would do the discriminant here. But I'll put the 0 on this side. Must be 2 and 2 plus and plus. And therefore, x minus 2 is the only point in common. Or it's like point of intersection. Let's just find the point for the sake of completeness. The point of intersection is when x equals minus 2, y equals x cubed, we'll use, which is minus 2 cubed, which is minus 8. Minus 2 minus 8 is the point of intersection, the only one. And we're done there. SQA Higher Maths 2025 last minute paper 1 question 17. Evaluate the integral between 0 and pi of 3 sine 2x plus 5x to the 4 dx. So start of exam papers tells us how to integrate sine. Sine goes to minus cos. So that gives me minus 3 cos 2x, but I need to then divide by the 2. So over 2. And then 5x to the 4 becomes, add 1 to the power, I've got a 5, divide by the new power, so that's just x to the 5. So plus x to the 5. Between 0 and pi, so I need to sub them in. So that's minus 3 over 2 cos 2 pi plus pi to the 5 for the first bit, minus 3 over 2 cos 0 plus 0 to the 5. And what's cos 2 pi and cos 0? Well, if you don't know, that'll graph the cos goes to 1, and at 0 it's 1, and at 2 pi it's 1. So it's just 1. So that gives me minus 3 over 2 times 1 plus pi to the 5 minus 3 over 2 times 1 plus nothing. So that's minus 3 over 2 plus pi to the 5 minus is plus, so plus another 3 over 2. So the 3 over 2's cancel out to just get pi to the power of 5 units squared. And I can't work that out, I've not got a calculator, so it's done there. SQA Higher Maths 2025 last minute, paper 1 question 18. Find f of x given that f dash x is 4x minus 3 and y equals 5x minus 7 is a tangent. A couple ways you could probably tackle this, but I'm going to take it the most obvious way. It talks about the tangent to f of x. So the gradient of the tangent equals 5, because y equals 5x minus 7, the number in front of x is the gradient, but f dash x is also the gradient of the tangent. So in other words, 4x minus 3 equals 5. So 4x equals 8, so x equals 2. So we've got x equals 2 as an x point of contact. So that means that when x equals 2, I can work out y. 5 times 2 minus 7, which equals 10 minus 7 is 3. So 2, 3 is the point of intersection. To form a point of intersection of 2, 3, we now need to find f of x, but we know f dash x, so we can integrate f dash x to get f of x back. So f of x equals the integral of f dash x dx. So we're integrating that. That's the integral of 4x minus 3 dx. So add 1 to the power, divide by the new power, but then you've still got a plus c. So f of x equals that, which is 2x squared minus 3x plus c. So really, we need to then find c. But we do know a point, 2, 3. So when x equals 2, y equals 3. So that'll get rid of my c for me. 3 equals 2 squared minus 3 times 2 plus c. 3 equals 2 2s is 4 times 2 is 8. 3 2s is 6 plus c. 3 equals 8 minus 6 is 2 plus c. So c equals 1. And therefore f of x finally equals 2x squared minus 3x plus 1. And we're done there. This is Mr. Clever for Clever Maths. Today we did Mr. Smith's SQA Higher Maths 2025 last minute non-calculator paper. Hopefully you found that useful. Remember, we've got our last minute live stream for members only the night before the exam. Take care, stay safe, and goodbye.